In the first Harry Potter, Voldemort is bonded to Professor Quirrell through magic. Harry Potter comes to stop Voldemort and Quirrell's evil plans. Harry Potter attacks the pair. During the attack, Quirrell is killed, leaving Voldemort and Harry.
This is an example of an SN2 reaction, which favors primary carbons. In this instance, the primary carbon is located in this acyl halide in between Voldemort and Quirrell, which acts as the leaving group. When Harry attacks as a nucleophile, he attacks the primary carbon and the leaving group leaves, which is Quirrell, forming a more reactive acyl halide.
Harry, Ron, Hermione, and Dumbledore team up to defeat Voldemort. Snape kills Dumbledore,
Avada Kedavra.
which leaves the trio vulnerable. In the end, Snape joins Harry, Ron, and Hermione because he was on their side the whole time.
This is an example of an SN1 reaction. An SN1 reaction favors tertiary carbons and only happens with bulky molecules. In this reaction, Dumbledore was the leaving group, and Harry, Ron, and Hermione were methyl groups, making it a bulky molecule. Snape was the nucleophile. Which caused the leaving group to leave, and a carbocation intermediate to be formed. When the nucleophile attacked, it replaced the carbocation and became part of the molecule.
Avada Kedavra.
Now we're going to review the differences between the SN2 reaction and the SN1 reaction. The SN2 reaction favors a primary acyl halide. The SN1 favors tertiary, which forms a carbocation intermediate. Now let's look at nucleophilicity. The SN2 reaction favors a strong nucleophile. This would be anything that's charged or basic, such as the hydroxide anion. The SN1 reaction doesn't depend on the strength for a nucleophile, but it would normally favor a weaker since the SN2 favors stronger. Next, let's look at solvent. The SN2 favors polar aprotic solvents because there's no hydrogen bonding. The SN1 favors a polar protic solvent because it can form hydrogen bonds and stabilize the nucleophile. Finally, let's look at the stereochemistry. After the SN2 reaction completes, there's inversion of stereochemistry because of the backside attack. When the SN1 reaction completes, it forms a racemic mixture. This is because it can attack from both sides.